Hi everyone! Today, we're diving into a frustrating issue many of you might encounter when working with the ATTiny826 and Arduino, unreliable UART serial transmission. You've carefully wired everything, uploaded your code, but the data coming out is garbled, missing, or just plain incorrect. It's a common headache, but often, the solution is much simpler than you think. You expect clear text like "Hello World" in your serial monitor, but instead, you see a confusing mess of strange symbols, question marks, or absolutely nothing at all. This isn't just an inconvenience, it makes debugging impossible and can halt your entire project. Let's break down the most frequent culprits and how to fix them. The absolute number one cause of garbled serial data is a baud rate mismatch. Your ATTiny826 serial.begin speed must perfectly match the speed set in your serial monitor software. If your code uses serial.begin 9600, but your monitor is set to 115200, you will inevitably get gibberish. Always double-check both ends. Another critical factor is the clock speed. The ATTiny826, especially when programmed with the Arduino IDE, often defaults to an internal oscillator. This internal clock might not be precise enough for reliable high-speed UART communication. Even a tiny deviation in the clock frequency can skew the timing of each data bit, leading to errors. This brings us to fuse settings. The ATTiny826 fuse bits control its clock source and frequency. If you're using a custom board definition or have previously flashed a different bootloader, these fuses might be incorrectly configured. For example, if the chip is set to use an internal 1 MHz clock but your Arduino core assumes an 8 MHz internal clock for serial timing, your UART will be wildly off. Incorrect pin assignments are also a possibility, though less common with standard Arduino cores. Always consult the ATTiny826 datasheet or your specific board's pinout diagram to ensure you're using the correct physical pins for TX and RX, which are typically PA1 for TX and PA2 for RX on the ATTiny826. Furthermore, power supply instability can wreak havoc on serial communication. A fluctuating or insufficient power supply can cause erratic behavior, including corrupted serial data. Ensure your ATTiny826 receives a stable 5V or 3.3V, depending on your setup. Lastly, if you're using an external USB to serial converter like an FTDI adapter, verify it's correctly wired, TX to RX, RX to TX, and that its drivers are properly installed on your computer. Now, for the solutions. First, always verify your baud rates. This is the easiest and most common fix. Second, stabilize your clock source. For better reliability, especially at higher baud rates, consider explicitly setting the ATTiny826 to use its internal 16 MHz or 20 MHz oscillator and ensure your Arduino core is configured accordingly. For absolute precision, especially in critical applications, an external crystal or resonator is the gold standard, providing a rock-solid clock source. If you use an external crystal, you must ensure the fuse bits are correctly set to utilize it. This leads to the third solution, checking and correcting fuse settings. You can use an ISP programmer to read and modify the fuse bits. Online fuse calculators can help you determine the correct settings for your desired clock source and frequency. Fourth, simplify and test. Start with the most basic serial code, like serial.begin 9600, serial.println, test, in your loop. If even this doesn't work, the problem is fundamental. While not a primary solution, software serial can sometimes be a useful diagnostic tool on different pins if hardware UART is giving you persistent trouble, but it's less reliable and more CPU intensive for long-term use. Finally, always consult the ATTiny826 datasheet and the documentation for the specific Arduino core you are using for accurate pinouts and clock configuration details. By systematically checking these points, you will very likely pinpoint the cause of your garbled serial data. It's a common challenge in the world of microcontrollers, but with a bit of methodical troubleshooting, you can get your ATTiny826 talking clearly and reliably. Thank you so much for watching. If this video helped you solve your UART woes, please give it a thumbs up, share it with a friend who might be struggling, and don't forget to subscribe for more tips and tricks on microcontrollers and electronics. Your support helps this channel grow. See you next time.